Okay, we're going to start learning about how to do confidence intervals with means today, but before we do that, let's do a little review, both multiple choice and I also would like to run through a full confidence interval with proportions one more time before we run into means. So let's go ahead and start with some multiple choice. A Gallup poll found that only 28% of American adults expect to inherit money or valuable possessions from a relative. The poll's margin of error was plus or minus 3 percentage points at a 95% confidence level. This means that, okay, so here we need to make sure that we are interpreting the confidence level in the interval correctly. So let's look at our answer choices. A, the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. B, the percent of all adults who expect an inheritance is between 25% and 31%. C, if Gallup takes another poll of this issue, the results of the second poll will lie between 25% and 31%. D, there's a 95% chance that the percent of all adults who expect an inheritance is between 25% and 31%. And E, Gallup can be 95% confident that between 25% and 31% of the sample expect an inheritance. Now, if you remember what we talked about in the last couple of lessons, confidence intervals are not tied to a specific interval. That level of confidence is tied in the process used to create this. That confidence level goes in the calculation of the margin of error. It is not tied to a specific interval. If you understand that, you could eliminate all but one choice just from that. Notice how B, C, D, and E all have that 95% tied to 25 to 31. And that's not correct. The only one here that is correct is A. The poll used a method that gets an answer to within 3% of the truth of the population 95% of the time. All right, let's look at the next one. Most people can roll their tongues, but many can't. Can y'all do that? Do you know what I'm talking about when you say roll the tongues? Like turn it into a, pull the sides up. I'm doing it right now, not that you can see me. It is interesting to see how many can and how many can't. The ability to roll the tongue is genetically determined. Suppose we are interested in determining what proportion of students can roll their tongues. We test a simple random sample of 400 students and find that 317 can roll their tongues. The margin of error for a 95% confidence interval for the true proportion of tongue rollers among students is closest to. Okay, well, I need to know what the margin of error is, right? Okay, if I'm dealing with proportions, and I know I've got a number out of a total, so I know it's proportions. When I do a confidence interval with proportions, on my formula sheet, it tells me that I should be doing the statistic plus or minus the critical value times the standard error. So my statistic with proportions is p hat, plus or minus my critical value is the number of standard deviations we are away from the mean, and that's measured by z-star, or z-score, times the standard deviation. And we know the standard deviation with proportions is the square root of p times 1 minus p over n, but because we don't know p, we're using p hat instead, which makes this the standard error instead of the standard deviation. Now, we're interested in the margin of error here, and the margin of error is everything after the plus or minus, right? So if I just want the margin of error here, well, first of all, I've got to find z-star. And z-star is calculated from the confidence level. Remember, if I have a 95% confidence interval, I'm looking at the middle 95%. So I need the z-scores that are on either side of that boundary. So I can do one of two things. I know if 95% is here, I've got 5% split in two tails. So that means I got 2.5 here and 2.5 here, or as area 0.025, right? So one thing I can do is I can go to my table and look here, find 0.025, which corresponds to a z-score of negative 1.96, right? That's a z-star. Or if you do on your calculator, you can go to inverse norm, put in the area, 0.025, mean, standard deviation, and when you hit enter, then it would give you 1.96 as well. Now remember, we're using the positive because we got the plus or minus there to take care of that. Times the square root of p hat. Well, how do I find p hat? Well, p hat I find by doing x over n. Well, x here is there were 317 who could roll their tongues out of 400 in the sample. So if on our calculator we divide 317 divided by 400, then we find that the proportion is 0.7925. So 1 minus 0.7925 divided by our sample size is 400. So now all I need to do here is crunch this out. So 0.7925 times 1 minus 0.7925 divided by 400. Square root of second answer times 1.96. And if you crunch all that out, you get like, I got 0.0397. So that's going to round up to 0.04. Okay, so make sure you understand if they're asking just for the margin of error, that's everything after the plus or minus. All right, 51, you want to design a study to estimate the proportion of students at your school who agree with the statement, the student government is an effective organization for expressing the needs of students to the administration. You will use a 95% confidence interval, and you would like the margin of error to be 5% or less, 0.05 or less. The minimum sample size required is, okay, remember when they say, okay, here's where I want the margin of error to be, I know the margin of error is equal to what we just solved for, right? So I'm just plugging in, I want the margin of error to be 0.05. Z star we already found for 95%, it was 1.96. The good thing about this is you start memorizing some of these that are real common. You just start memorizing those Z stars and you don't have to look them up every single time. P hat, now if there's no P hat, or even if there was, that would just be from one sample. And so this would tend to vary depending on the samples. And so what I want to do, if you remember from the notes at the end of the notes from the last class, what I want to do is I want to put in a P hat that would estimate for me where it would give me the largest sample size I need no matter what P hat I use. And that happens when P hat is 0.5. So I'm going to plug in 0.5 for P hat, and then I'm just going to do a little algebra and solve for n. So I'm going to say 0.05 divided by 1.96 first. So I'm dividing that away over to this side. Then I'm going to square both sides to get rid of the square root. Then I'm going to multiply n over to that side. And then when I multiply that, that's 0.25 divided by second answer. And you end up with something like this. But remember, we can't have a partial number, right? So the minimum sample size I need then is 385. All right, let's try one more multiple choice, and then we'll run a confidence interval for proportions. A newspaper reporter asks a simple random sample of 100 residents in a large city for their opinion about the mayor's job performance. Using the results from the sample, the C% confidence interval for the proportion of all residents in the city who approve of the mayor's job performance is 0.565 to 0.695. What's the value of C? Okay, so what I have here is I have an interval. I'm told, okay, it goes anywhere from 0.565 to 0.695. So if I'm thinking about my interval here, my formula, what is P hat? What was the starting point? Well, that would be the number right in the middle, right? So if I added these two together and divided by 2, it would give me the number right in the middle, which is P hat. And so if you do that, that gives you 0.63. Okay, well, what's the margin of error? Well, what am I adding and subtracting from each side? So I could say 0.695 minus that and figure out what I'm adding and subtracting each side. And if you do that, it looks like you are adding and subtracting 0.065. Okay, now it wants to know the confidence level. So how can I figure out the confidence level? Well, how does the confidence level play into this formula? The confidence level affects Z star, doesn't it? So if I can figure out what Z star equals, then I might be able to figure out the confidence level. Okay, well, I know that everything after the plus or minus is equal to this right here, don't I? So let's set that up. 0.065 equals Z star times, okay, well, I actually know P hat as well, don't I? That's 0.63. That was what we found earlier. So 0.63 and 1 minus 0.63 over, do I know the sample size? Well, yeah, it said we had a simple random sample of 100. Okay, so I could do a little calculation here. So 0.63 times 0.27 0.37, sorry. So 0.63 times 0.37, then divided by 100. Then we're going to square root all of that. Okay, and then I need to say 0.065 divided by all of this. And so I get that Z star equals 1.3, I'll round it to 5. Okay, now, what is that telling me? Okay, well, that tells me that, remember when I do confidence intervals, I'm looking at the middle whatever percent, and this is what I want, right? I want to know what middle percent I'm looking at. Well, if this is Z star, that means that on this side, it's that, and on this side, it's this. If I want the area between, if I found each of the p-values, could I subtract it and find the confidence level there? Sure. So if we grab our table A, and we look at negative 1.35, I get 0.0885. Is the p-value, so that's the area to the left here. If I look up positive 1.35, I get 0.9115. And so the difference between these two, if I say 0.9115 minus 0.0885, the difference is 0.823, which means that 82% would be the confidence level. Okay? All right, all of these were good questions to make sure you understand the makeup of your confidence interval. All right, let's try running through a full confidence interval real quick before we move into means. Okay, so in January of 2010, a Gallup poll asked a random sample of adults, in general, are you satisfied or dissatisfied with the way things are going in the United States at this time? In all, 256 said they were satisfied, and the remaining 769 said they were not. Construct and interpret a 90% confidence interval for the proportion of adults who are satisfied with how things are going. Now remember, there are a couple of things I want to cover. I want some sort of introduction. I want a statement of what I'm going to do. I then want to check my conditions. I want to show my formula and plug in. And then I want